Dear students, today's lecture is on page 129 up to page 131, and it had to do with the reduction of nitrate. Now, in the nitrogen cycle, bacteria plays a very important role there, and they are also responsible for reducing nitrate to nitrite to ammonia to nitrogen gas. And we can test it. And on this reduction of nitrate, we can see what is the role of bacteria in that process. In the overview on page 129, they say a biochemical characteristics of many bacteria is the ability to reduce certain compounds, and nitrate is a typical example of it. And the reduction of nitrates of some bacteria occurs in the absence of molecular oxygen, and therefore they can do respiration under anaerobic processes. Why? Because they can use nitrate as an electron acceptor. What happens when nitrate receives an electron? It converts it now to nitrite. So anaerobic respiration, we're doing respiration under aerobic conditions. There is bacteria that can do respiration under anaerobic conditions. Under aerobic conditions, oxygen is the final electron acceptor. But in this case, the bacteria can use sulfates or nitrates to work as an electron acceptor. All right. So they're changing it then from nitrate to nitrite. After the reaction, they say, okay, in the reaction they say, this is being done by the enzyme nitrate reductase. This reaction can be detected by growing the organism in a medium containing nitrate. Now, if you look under the materials, you will see that they're using trypticase nitrate broth. What does it say to us? Nitrate broth. So there is nitrate available for the bacteria. And we can see by doing some chemical tests afterwards, after incubation, we can see if the bacteria can change this nitrate to nitrite or maybe to gaseous products like ammonia and nitrogen gas. They say there also, underneath that first reaction, they say there, this reaction can be detected by growing the organism in a medium that containing nitrate. Some bacteria have the enzymatic ability to react on the nitrate to reduce it to ammonia and further on to nitrogen gas. And that you can see. Remember that ammonia and nitrogen is both gases. Now, how can we see gas in a test tube? We learned it in that lecture on carbohydrates, the fermentation of carbohydrates. We put inside the test tube a inverted Durham tube, small test tube, and that Durham tube is trapping gas. So in this trypticase broth, nitrate broth, there's also a Durham tube inside there, and that Durham tube can catch for us then either the ammonia or the nitrogen, and so we can see if the bacteria can produce from nitrate straight through to gaseous products. Okay, they give you also the reactions there from nitrite to nitrogen gas. Now, we inoculate this broth. We inoculate it then with the bacteria. We incubate it at 37 degrees Celsius for 24 hours. And then the next day, we're going to follow the procedure that's on page 130. And see now how clever this results taking is been described here for us. Add approximately 1 mol sulfonylic acid and 1 mol dimethyl alpha-naphthylamine into the tube. Development of a red or a purple color or a maroon color, it depends on how you see it, indicates the presence of nitrite. Now, they show us the reaction there. I want you to know, what do I need to add to this trypticase nitrate broth after incubation? What do I need to put into to see if there's nitrite present? 1 mol sulfonylic acid, 1 mol dimethyl alpha-naphthylamine. Okay, and there's the reaction, and we must know that reaction. And we must know the structure of sulfonylic acid, that's colorless, dimethyl alpha-naphthylamine, that's also colorless, plus HNO2, that is your nitrite. If these three things is coming together in a test tube, they forming sulfobenzene azodimethyl alpha-naphthylamine, and that is a red or a maroon color. See, now if we see this red color, it means the bacteria produce from the nitrate nitrite. Let's say there's no color change. Either the bacteria cannot break down the nitrate, or they convert it further than nitrite, meaning that they produce now nitrogen gas and ammonia. How can we see that? We can see that by the Durham tube inside the test tube. If the test is negative and we think the nitrate is not reduced, the bacteria cannot break down nitrate to nitrite, what can we do? They say, therefore, it is desirable to test further those tubes that's giving a negative reaction and we do not see gas into the Durham tubes. This can be done with the addition of a very small amount of powdered zinc. The zinc will reduce the nitrate to nitrites, and without adding any more of sulfonylic acid or dimethyl alpha-amine, because those two reagents is already present there. If the zinc can break down the nitrate to nitrite, then immediately the red color will appear. All right, and then we know, on that stage we know the bacteria cannot break down nitrate. So, I hope that you find this very interesting. Learn all the reactions, learn the media that we need, learn also the reagents, learn the structures, learn if we're putting three things together, what is being formed and what is the colors of each one and how can we test the different stages. Okay, students, all of the best for you and God bless.